Welcome. Let's solve a problem about standing waves. For that, we will consider a wave on a string. So this is the problem. A string with a length of 4 meters is held under a constant tension. The string has a linear mass density of 0.006 kilograms per meter. Two resonant frequencies of the string are 400 Hz and 480 Hz, and there are no resonant frequencies between both those frequencies. A. What are the wavelengths of those two resonant modes, and what is the tension in the string? So let me first write down all the data for these problems, the mass density, the length, and both frequencies here, and let's try to solve for the first part. So we know that the resonant frequencies satisfy these relationships, so for the wavelength and for the frequencies, where v is the velocity and f sub n is just the frequency sub n, and we have two, and because there is no intermediate frequency in this case, one of the frequencies is f sub n and the other one is f sub n plus 1, and we just extend for those particular cases n and n plus 1 the general expression of these resonant frequencies. What we can do is divide one frequency over the other one, and then most things will cancel here, and we'll have that the ratio of frequencies is just n plus 1 divided by n. Then we can just substitute those values for 80, 400, and then substitute and then solve for n, and here we get that n is equals to 5. So the resonant frequencies are f sub 5 and f sub 6. Now, in order to find the wavelengths, we need the velocity. So look that the velocity is just the frequency multiplied by the wavelength, so we need to find that velocity. For that, we go back to f sub n, and then here we'll have the velocities. We have n that we already know it's 5, and then we have the length, which is 4 meters. So we substitute here 400 is equals to 5v divided by, and then we solve for the velocity, and we get that the velocity is 640 meters per second. With that in hand, now we can go back to the general expression of lambda, 2 divided by n multiplied by L, and then substitute n equals to 5 and n equals to 6. In this case, one is consecutive of the other one. For that, we get that one of the wavelengths is 1.6 meters and the other wavelength is 1.33 meters. Now, let's go to solve part B. What is the tension of the string? And to answer that, I can use the following relationship, that the force or tension is equals to mu times v squared, where mu is the mass density and v is just the velocity of the wave. Then I substitute 0.006 times 640, and I get 3.84 newtons as the tension on the string.